How do you determine sample size for a binomial population? Well, in binomial population, the procedure works pretty much the same way, where you have the margin of error equal to z times the standard error of p. Now you exchange terms and solve for n, and you get z squared, then pi times 1 minus pi divided by e squared. Okay. Now in the case of sample proportion, it so happens that we don't know the value of pi, so we have to estimate. We have to take a pilot sample and estimate what the pi value will be, and we want to use that pi value, that p value here in place of pi, the value of p in place of pi. But it so happens that if you take different values for pi, so pi has to be between 0 and 1, it is a proportion. So if you take values of pi from 0 through 1, various values, and then compute pi times 1 minus pi, and you will see that pi times 1 minus pi goes up and up and up, and it reaches a peak value when pi is 0.5, and then it will go down and down and down and again and go to 0. So the maximum value occurs when pi is equal to 0.5. So to be on the safe side, we can always use pi equal to 0.5, and that would overestimate the sample size required, but at least it will guarantee that the margin of error will not exceed the limit that you have set up. So if you don't want to take a pilot sample, you can simply plug in a value of 0.5 for pi, and that will work also. So let's look at an example. So we're going to use 8.46, where we have a Nielsen mobile shopping report that looks at how customers using mobile devices throughout their purchase journey. Okay, in the response question, how do you use your mobile device? About shopping, 27% of the tablet owners said they use their mobile device for payment. 21% said they use it for social media comments, and 10% said they use their device to retrieve mobile coupons. So we want to construct 95% confidence interval. If we take a sample of 300 tablet owners, okay, what will be the confidence interval? So here we have first A, B, and C are the confidence interval for the three modes, and then in D we come to computing the sample size. So part D is the sample size computation with 95% confidence, and we want within plus or minus 0.02 for the margin of error. So for problem 8.46, we have sample of 300, okay, and we want confidence level of 95%. So which means 1 minus that is alpha. So our z table value is 1 minus z is that norm.s.inv 1 minus alpha over 2. So that's common for all the sections. So let's put that there. Now for part A, we want to look at tablet owners who use the mobile device for payment. So success here is mobile devices used for payment. So we want pi is the proportion of tablet owners in the population they use the mobile device for payment. So P here is the sample. Okay, so 27% is what your 27%. So if you go to part here, 27% mobile owners for payment, right? So then S of P is square root of P times 1 minus P over the sample size n, and I'm going to make that absolute reference so we can copy this. So we're going to repeat the computation for those three conditions. This is confidence interval that we have done before. So that's S sub P. So 98% margin of error is Z, and I'll absolute reference that, times S sub P. Okay. And the lower limit is that minus margin of error, and then that plus margin of error, are the two limits. So then we can interpret in this fashion. Okay. Now for B, when the subscriber uses, the mobile device user uses a tablet for making comments, so social comments, that's your success. So the population and then sample. So now your P is 21%. Okay. And then the rest of the computation is exactly like what we have in A, so we can copy paste that. Okay. And then provide an interpretation, which we have done here. And then the final one is for coupon. So for retrieving coupon, again, pi is the proportion in the population, P is the proportion in the sample. Now P is 10%. Okay. Now we copy the computations here, and you get the interval for the third category. Now the question is, okay, we have the same 95%. So this is like before. So 1 minus alpha, and then Z is norm dot S dot INV, then 1 minus the top tail. So that will give us the Z value. Now we want the margin of error to be 2% in each of those cases. Okay. So we have the three cases A, B, and C, where the P is 27, 21, and 10%. So this is 27%, this is 21%, and this is 10%. So then what is the value of N? So we go Z, and we make that absolute reference squared, Z squared, okay, times P. Now this should be absolute referenced for times P. We don't need to absolute reference that. Then 1 minus P, pi times 1 minus pi, but we are using the estimates, divided by E squared. So E squared should be absolute referenced. Okay. So then we do a round up of that to 0 decimal places. So we copy across. Okay, so these are the sample sizes we want. So the largest one is what we have to use. Now if we don't know what the p-value is, we can always use 25%. See here, if I change this to 25%, you see that the sample size will increase by a 50. If you don't know what the estimate for pi is, and we want to be on the safe side, we can always use 50%. When we use 50%, you will see the required sample size will be on the conservative side, which will be a little bit larger. So you end up with 2400. So quite a bit larger.